Okay, so the next special sequence is geometric sequences. And we have the formula for summation in here too. If we're nth term, basically what a geometric sequence says, if you take a term, a sub n, and you divide it by the term right before it, a sub n minus 1, we're always going to have the same constant r. R is called the common ratio. Okay, so that's one of our formulas. Just like the arithmetic sequence, this has 3 formulas. The second formula, we can tell that a sub n, if we multiply both sides of our equation by the term right before that, and the equation above, that's going to be the same thing as r times a sub n minus 1. That third formula, let's do what we were doing before. So we're going to use that second formula, and let's look at what a sub 2 is and see if we can find some pattern. If we look at a sub 2, that equals the term before it, which is a sub 1 times r. A sub 3, well, that is equal to, by this formula, the term right before it, a sub 2 times r. Well, from above, we know what a sub 2 is. So let's replace what a sub 2 is with what we have above, a sub 1 times r, which if we simplify, this is a sub 1 times r squared. A sub 4, that's equal to the term right before it, which is the third term, times r. But from above, we know what a sub 3 is. So this is a sub 1 times r squared times r, which is a sub 1 times r cubed. One more. So if we have a sub 5, this is equal to the term right before a sub 4 times r. But a sub 4 from what we just found was a sub 1 times r cubed, and then times that r. So a sub 1 r to the 4th. So notice that each one of these has a sub 1 in here, all times r, but r is raised to the power 1 less than our term in the sequence. So our third formula is a sub n is equal to our first term, a sub 1, all times r raised to the n minus 1 power. So let's say you want to show that something is arithmetic. Not arithmetic, geometric. So let's say you have c sub n. This is equal to 2 raised to the n minus 1 power all over 4. And we want to show c sub n is geometric. So we need to show that if we take our nth term, divide it by the term right before, we're always going to get some constant r. And r is always the same number. So we know what our c sub n term is from above. That's 2 to the n minus 1 all over 4. And this is divided by, now if we plug in n minus 1, wherever we see that n in here. So we're going to have 2 raised to the n minus 1 power, and then minus 1 all over 4. can think of this as division, a fraction divided by a fraction. So this is the same thing as 2 to the n minus 1 power over 4 times the reciprocal of the second fraction. So 4 all over 2 to the n. I'm going to just combine minus 1, or negative 1 minus 1 is minus 2. Notice our 4's cancel. And we can use our rules of exponents. So the quotient rule of exponent, if you have the same base, you subtract your exponent. So the exponent on the top minus the exponent on the bottom. And so from that rule, we have 2 to the n minus 1 minus this exponent on the bottom n minus 2. So 2 to the n minus 1 minus n plus 2. So notice the n's cancel in the exponent, and we're left with 2 to the first power, which is 2. So because we got a common ratio of 2, so we have r is equal to 2. And so because that was a constant, we know that is geometric. If we had tried to show this and we were left with n inside after we did all this work, then we would say that it's not geometric. Okay. The following says determine whether the given sequence is arithmetic, geometric, or neither. So it would be the same sort of idea that we were just doing. Let's look at one that doesn't give us the formula. So what about -1, -2, -4, -8, ... Let's see if we can figure out what that formula is. So notice that it looks like 2 to the 0 power, 2 to the first power, 2 squared, 2 cubed. So to me, this looks like this is -1 all times 2 raised to the n minus 1 power. And again, we can try it. If n is 1, we get 2 to the 0 power, which is 1 times -1 is -1. If n is 2, the second term, we get 2 to the first, which is 2 times -1. So this is our a sub n term. Well, if it was arithmetic, then a sub n minus the term right before has to equal some constant v. And if we had -1 times 2 to the n minus 1 power minus a sub n minus 1, that's -1 to the 2 to the n minus 1 power. So this is negative of 2 to the n minus 1 plus 2 to the n minus 2. There's n still left in this, and we can't simplify this any further because they're not like terms. So this is not arithmetic. Geometric, though, says if we take the term divided by the term right before, we better get back some constant r. So we're given, or we found out what that term was. So that was -1 raised to the 2 to the n minus 1 power divided by the term right before, which we saw was 2 raised to the n minus 2 power. So this is equal to -1, same base, of 2. So we take the exponent on top, n minus 1 minus the exponent on the bottom, n minus 2. So we have -1 all times 2. The ends are going to cancel, and we're just going to get to the first power. And so we get back -2. So we can see that r is equal to a constant. So it's geometric. If n had been left in there, then it would have been neither arithmetic or geometric. Okay, so if we're looking at a summation of a geometric sequence, we're going to use this formula. There's one other formula in here that is helpful. Actually, if our common ratio, r, if the absolute value of that is less than 1, then the summation from k equals 1 to infinity of a sub 1 times r raised to the k minus 1 power. This is actually means it's convergent. It's going to sum to one particular number. Then this is equal to the first term all over 1 minus r. So this means that the sequence converges. So let's look at one example. Let's go up here. Find the sum of the following. Let's say you had the summation of k is equal to 1 to infinity of 1/2 all times 3 to the k minus 1 power. Well, looking at our formula, we want to see, so find the sum. Oh, determine whether each infinite geometric series converges or diverges. If it converges, find the final sum. Sorry. That wasn't the whole. So basically, we want to know, does it converge or diverge? Well, we need to figure out what r is. And r in our case, I can see is 3. This is not less than 1. So this diverges. Diverges. Or maybe we have the summation from k equals 1 to infinity of 8 times 1/3 raised to the k minus 1 power. So our r value in here is 1/3. It's less than 1, so we know it converges. And if we look at our formula, We need to know what our first term is. Oops, that's not the right formula. We need to know what the first term is. So looking at this, our first term is 8. So a sub 1 is 8. So this is equal to 8, 1 minus r, which is 1/3. So this is 8 all over 2/3. So 8 times 3/2. 2 goes into 8 4 times. So this gives us back 12. So if you summed an infinite number of terms of this sequence, 8 times 1/3 to the k minus 1, you would get that that is summed to 12. Okay, so I need to stop here. So hopefully that gave you enough information to do some problems. I'm going to start tomorrow's class for my college algebra doing some problems of these sequences and series. I will post the videos for you guys so that you have some extra problems if you want. We're also going to be reviewing in the section tomorrow for the final, and so you're welcome to join if you want, but I'll post the videos for the review for you guys.